This 1 week?
This
Yes. I thought you meant this 1 week. I was like, I kind of felt bad about this week too. All righty, if you will get your notes out, we're going to go ahead and move on to electronic configuration. On electronic configuration. All right. So the periodic, let's try that again. The periodic table, the one that you've colored, helps with the order of electron filling, as they fill from lowest to highest energy. And then on the periodic table, each box represents an electron. So it's just kind of a tool. And that's yours to do as you start working some more problems. You know, you may want to add more or adjust it. You know, you could put every element on there if you wanted to. I just kind of put a few here and there to help me find what I'm looking at. And the reason this looks a little bit different than our one above, if you notice period 7 on this one is completely filled out. And there it stops before we get to the P block. So that's why it looks a little bit different. All right, so I'm going to switch to my periodic table real quick. Whoops, try that again. So whenever we look at these different numbers and the different letters, we talked about them yesterday. So like on the 1, 2, 3, and 4, those are the energy levels, are the principal quantum level. The S, P, D, and F are going to be our sublevels. So this is used, like I said, as a system to show you what gets filled first. So the lowest energy is the 1s. So that's why it's written first. So this is the first electron in the 1s. This is the second electron that goes in the 1s. When you finish the end of the period, you come back to the beginning of the next period. So after 1s, my next thing that would get filled would be my 2, so energy level 2, sublevel S. And once again, an S holds 2 electrons, so that's 1 electron 2. And then my next thing would be my 2p. So when I finish here, I come back and I start my 3rd energy level. So that's how you use it. It tells you the order that the different energy levels and sublevels are filled. Notice when I get to period 4, I have 4s, just like all the other ones, but then I have 3d. That's because even though 3d is in energy level 3, it's higher energy than the 4s. So that's why the 4s is listed first. The electrons will go into the 4s, and then if there's more electrons, they will finally fill the 3d. So if you notice, that's why N-1 is written here. I may be in period 4, but whenever I talk about my D, it's energy level 3. Same thing if you get way down here to your Fs. This first F comes from right there. So it's in period 6, but that's energy level 4 for that F. That's why you have N-2. And once again, that means because anything before it is lower in energy and the electrons go into it first. So that's how we're going to use this as a tool. We talked yesterday about the fact that an S can hold has only 1 orbital and it can hold 2 electrons. That's why all of your S's have 2 boxes for them. My P's have 3 orbitals. Each one can hold 2 electrons. So if you notice for my P's, if I count across 1, 2, 3, 4, 5, 6, representing the 6 electrons. My D's, 5 orbitals, so 10. If I count across there, I have 10 boxes. And my F, how many boxes do you think I have for an F? 14, exactly, because they can have 7 orbitals, 2 electrons in each. So if I count across, I have 14. So that's kind of how we use this for a tool. All right, let's look at some of our other things. So some of this, we talked about it yesterday, and it'll make a little bit more sense today. And hopefully you watched the video. Unoccupied orbitals are represented by a line. We said that S always has 1 orbital. It doesn't matter what energy level it's on. So it's just going to have 1 line. P's always have 2 orbitals. So they will always have 3 lines when we start drawing our diagrams. A D has 5 orbitals. So 1, 2, 3, 4, and 5. And then my F has 7 orbitals. So 1, 2, 3, 4, 5, 6, and 7. The lines are labeled with the principal quantum number and the sub-level letter. So let's say that I was in 2P. Because it's a P, it would have 3 lines, and I would label it with the energy level, with its principal quantum number, and then what sub-level it's in. Arrows are used to represent electrons. We talked about that yesterday, and we have one going up and we have one going down to represent opposite spins. So those are going to be my arrows. One will go up and one will go down if you need that many electrons. Also, don't forget Untitled Rule. It says all orbitals in a sublevel get 1 electron before doubling up. So if you notice, whenever I was filling in these, I was putting 1 in each line before I doubled up. That's what we mean by that. If we were in 2P, again, I'll just use that as an example. And I have 3 orbitals and I need to put 4 electrons in there. I have to put 1 in each before I double up. And once again, that's because they're negative. So they're trying to do anything they can to get as far apart as possible. So this is for the first and longest kind of notation. It's called orbital notation. It's our longest. Then we have configuration notation, or sometimes you'll see it as longhand notation, and it's kind of in between. And then we'll get to our noble gas notation, which is your shortest notation. So for the longhand notation, for this one right here, the one that's kind of in the middle, the number of electrons in a sublevel is indicated by adding a superscript to the sublevel. So in other words, this right here would be my orbital notation. If I wanted to turn that into configuration notation, I would put 2P, but instead of drawing the arrows for electrons, I would use a superscript. So since we had 1, 2, 3, 4, I would say 2P4. So it just takes the lines and the arrows out, and the superscripts are going to represent your electrons. And then for our shortest one, I'm going to move this up in a minute if everybody's ready. So the noble gas one is the nice short one. So with the noble gas, the configuration begins with the preceding noble gases symbol, and it's in brackets. And then it's followed by just the rest of the configuration for that particular element. So this element right here that it's representing is chlorine. if I drew chlorine out, not drew it out with my orbital diagram, but did it with my electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p5. So if you look at chlorine on your periodic table, it's element number 17. So the noble gas that before it is neon, so we use it. And the neon represents all of this. And then I just have to write what's in the period to get to my element. So then I would just write 3s2, 3p5. So it's letting a noble gas take up some of the configuration to shorten it. A noble gas cannot represent itself. So if I was like writing the noble gas notation for argon, I could not just put argon in brackets. I would still have to use the preceding noble gas. Some things you need to know are the highest occupied energy level. So those are the electrons containing the energy level with the highest principal quantum number. And remember, your principal quantum numbers are just your whole numbers. 1, 2, 3, 4, 5, 6, 7. It could go on, but that's about as far for the elements that we have right now that you would need. So on this notation, if I use this notation, the electrons that are in the highest occupied energy level would be these electrons. Because 3 is my highest principal quantum number. So the electrons in the S and the electrons in the P would be my highest ones. You also have your inner shell electrons. So those are electrons that are not in the highest energy level. They're also called the core electrons. We talked about those during periodic table trends. So for this element, that would be all of those that we circled. 1 and 2, those are lower principal quantum numbers, and 3, so those are your core electrons. If I drew this with a Bohr, and you don't have to draw this if you don't want to, because we know now it's not really a true representation. But these right here, this would be considered principal energy 1, this would be considered principal energy 2, and this would be considered principal energy 3. So these electrons in the S and the P would be located in that outer energy level, and these in here would be my core electrons. The octet rule still falls into place, and that says that the highest energy level S and P electrons are filled when they have 8 electrons. So those are characteristics of your noble gas. Our exceptions are hydrogen, helium, and beryllium, because they cannot have a full 8 octet. They don't even have enough electrons to do that. You also have your valence electrons, which are going to be your outermost S and P electrons. So if I used magnesium as an example, and I wrote out its longhand configuration, it would be 1s2, 2s2, 2p6, 3s2. So from looking at that, how many valence electrons does magnesium have? 2, exactly. It's your outermost. So my outermost, I have 1, 2, 3. So this is my highest number. So that's my outermost energy level. And the electrons that are on S and P, I only have an S. So those are my valence electrons. And we know that that's what they have because it's in period 2. All of these that I'm going to box in, those would all be core electrons. All right, let's work a couple together and then y'all can give it a try. All right, I'm going to switch to my periodic table because I can write all over mine and erase it. All right, so we are going to do, what are we gonna do? So we're gonna do argon. And it's element number 18. So that means it has 18 protons and 18 electrons. So I need to find a place for 18 electrons. So it's the third noble gas down. So it's located right here. That's what we're shooting for. So I'm going to start with the orbital diagram, and you always start at the very beginning. So it gets very repetitive. So the first thing that I have is 1s. So since it's an S, it'll just have one line. And it's before the element I'm interested in. So it's full. So I'm going to give it 2 arrows. That's all that I have in period 1. So now I'm going to come to period 2. So the first thing that I have in period 2 is my 2s. Once again, just one line because S's have one orbital and it is full. So I'm going to draw 2 electrons. So that puts me right here. So the next thing I have is a 2p. So since it's a p, I'm going to draw 3 lines. And it's still before argon, so it's going to be full. So I'm going to say 1, 2, 3, 4, 5, and 6. All right, that's all I have in period 2. So now I'm in period 3. So the first thing I have is 3s. So it's full, so I'm going to give it 2 electrons. And then I come across, and finally I have the area that argon's actually located in, 3p. So 1, 2, 3. And then I count how many electrons in the element is. In this case, it's 1, 2, 3, 4, 5, and 6. So I need all 6 electrons. So 1, 2, 3, 4, 5, and 6. So if I've done it correctly, how many arrows should I have? 18, right? Because we said it's element number 18. And do I have 18? I do have 18. Does it make sense that argon, which is a noble gas, has 8 valence electrons? Yes. Okay. So that's my longest one. That's called my orbital notation. To get from that to my configuration or longhand notation, I just turn the arrows into superscripts. So it becomes 1s2, 2s2, 2p6, 3s2, and 3p6. So in case I haven't said it, you'll see it gets a little bit repetitive because you're always starting the same way. Now, if I want to do noble gas notation, I go to the noble gas before argon, which is right here. So that would be neon. So I put neon in brackets. And then I just write what's in the period that argon is in. So argon is in period 3. So that means I have to just do 3s2, 3p6. So we let neon in brackets stand for all of that. Because if we wrote the configuration for neon, it would be that. So instead of writing it, we're letting that noble gas stand for that. Anybody have any questions yet on that? It looks, it's not as hard as it looks, but it does get very, like I said, a little bit repetitive. All right, let's look at another one. If y'all should have some place to do practice. The only thing that you don't want to is y'all have one page that says exceptions to electron configuration with some space below it. We'll need that tomorrow, so make sure you just leave that blank. All right, let's try one that's a little bit different. So this time we're going to do iron Fe. And it has element number 26, so it's right here. So what side locate my element? One thing that I like to do is I like to say what should be my very last electron. So iron is in 3D. So my very last thing I should be writing is 3D. And then if I count my boxes in 1, 2, 3, 4, 5, 6. So 3D6 should be the very last thing I write. So I do that. So like if I start get lost or whatever, then I can kind of find out where I should be. So once again, start where you start. 1s. 1s is always going to have 2 electrons, except if it's a configuration for what? For hydrogen, right? Helium would be just like this right now. We would stop right there for helium because it's the second one. So hydrogen would have 1, but everything else is going to have this and more. So 1s, and then I go to my 2. So I got 2s, and that has 2, and that brings me across to here, 2p. So since it's a p, I'm going to give it 3. And it's full because once again, I'm trying to get down here. So everything before it is full. So 1, 2, 3, 4, 5, and 6. And that gets me to period 3, where a period always starts with an S. And then it takes me across to my 3p. 1, 2, 3, 4, 5, and 6. Brings me back to my 4, which I'm getting close to my element. So I have 4s. And then finally, I'm where my element, I'm in the line my element is, and it's 3D. Even though it's in period 4, the D's are one behind. So a D would have 5. You draw all the lines, even if they're not going to have any electrons in them. So this one is 3D, and we said 1, 2, 3, 4, 5, 6. I need 6 electrons, so I'm going to do 1, 2, 3, 4, 5, and then finally I will double up to get my 6 electron. So if I count all of those, I should have 26, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25, 26. So I do have my 26 electrons. Anybody have any questions on that part of it? All right, now I'm just going to take that and put that in my longhand. So all I'm going to do is replace my arrows with a superscript. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and finally 3d6. That last one's a 3d6, which is where I said I was going to be to begin with. All right, and then noble gas notation. The farther you get in the periodic table, the more that we appreciate the noble gas notation. Whoops, I didn't mean to do that. All right, so here's iron. So what's going to be my noble gas that's going to start it? Argon, exactly. So I put argon, and then all I have to do, since iron is in period 4, I only have to write anything in period 4. So that's 4s2, 3d6. So that means instead of writing all of that, I let Argon take care of that. So you can imagine if you were trying to write the configuration for some element way down there, that the noble gas is very, very nice to use. All right, I want y'all to try element number 53, which is iodine. And it's right here on your periodic table. Like I said, it looks a little different because of the way that our periodic tables. But it's element number 53 right after TE. So try the 3 different types. Anybody wearing costumes tomorrow? You don't even wear costumes? Probably not. Halloween on Sunday? I don't think you are either, but we haven't got anything yet. Usually they send us something, but I feel like they will wait till the last minute. I don't know. I haven't got anything yet that says y'all can't, but I feel like sometimes they don't give that information until it's like almost too late. I'll try to ask during my conference period, 7th, and see. I'll put it out on Sports U, but yeah, probably. I guess I won't wear my witch's costume, which is just my everyday outfits. All right. So what is our very last thing that's getting filled? 5p to the 5th. All right. So that should be our last thing. So we're just going to start from the beginning. It's a little bit boring, isn't it? If you teach it 4 times a day, it's really boring. So, all right. So we got our 2s and then we got our 2p. So we're going to put in there. And then I'm going to start period 3. So I start with my 3s. What did I do? Here, up here. That's okay. Then we go to 3p. Oops. Now I can't even write the right numbers. Now you got me flustered now. 1, 2, 3, 4, 5, and 6. My arrows are getting pretty lazy. All right, 4s. And then from 4s, we have our 3d. 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then I have my 4p. Two, 3, 4, 5, and 6. Next is my 5. Maybe I'll switch colors here. So I did give myself enough room. 5s. And then my 4d. 2, 3, 4, 5. 3, 4, 5. Are we good so far? And finally, got to where I'm interested in my 5p. 1, 2, 3. And we said we needed 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. All right. So that would be my long one. And then my longhand configuration, you would just turn your arrows into superscripts. So I'm going to do that. 2, 3p6, 4s2, 3d10, 4. What happened to my 4p6, 5s2, 4d10, and 5p5. All right, I know it. It's gonna have to feel better too. So then what would be the nice noble gas notation? So what's my noble gas I'm gonna use? Krypton. And then what would I need to put behind my krypton? 4d10 and 5p5. So all of this, before I change to red, I'll pretend like I did that on purpose. That krypton stood for everything else. All of this I didn't have to write, because that's what krypton stood for. All right, so y'all please do a little practice at home. Tomorrow I'm going to show you how it is if you have to go down into the F, because it's a little bit tricky. And then I'm going to show you ions and some exceptions. And then we'll probably have a quiz over this on Monday. And you can use you'll be able to use your notes, and you'll be able to use your little cheat periodic sheet or whatever you want to call it. close up electron configuration for a minute. Instead, some AP chemistry.